Hey guys, I hope you guys are doing great. So in this video we are going to see how we can create a machine learning model based on simple linear regression. So if you haven't subscribed to my channel yet, hit the bell icon and subscribe to my channel right now so that you don't miss anything. So let's begin. So first and foremost thing what we are going to do is we are going to import the necessary libraries that we want to create this model. So I'm importing pandas, numpy, seaborn and matplotlib, and I'm going to execute it, and then let's collect our data set. So I'm going to use the mpg data of seaborn, and I'm going to call it using sv load dataset into df, and this is my data set. So my data set contains a lot of variables, but our use case is that we want to predict the mileage based upon the weight of the vehicle. Okay, so let's move forward. Now what I'm going to do is I'm going to just check if there is any kind of a relation between my mpg and weight, that is the mileage and the weight of the vehicle. And so what I'll do is first I'll scale the mileage and the weight column using the min max scaler, and I will call this min max scaler in ler, and I will transform this using fit transform, and on which I want to apply it, I will apply it on all the rows of weights and mileage. So this way I'm going to first transform it, and this data I'm going to pass it in the scatter plot of seaborn, and I will name those labels and the x-axis and the y-axis as weights and mpg respectively. And now let's execute it, and what we see is this kind of a scatter plot, and you can see there is some kind of a red line we can see between these two. Now what we can do is let's just check using the correlation whether is there any kind of a dependency between these two or not. So what I'll do is I'll simply call this particular data, and I will apply correlation to it, that is the correlation function dot corr, and we can see there is a high correlation, that is minus 0.83. so this means that there is a negative correlation. So the more the weight, the lesser the mileage of the vehicle, and that pretty much makes sense. And I see that it's a kind of a decently high correlation. So let's continue. So I will segregate this data into two variables, that is x and y. So x represents my independent variable and y represents my dependent variable. Okay, so now I'll execute it, and why I have named it x and y, because this will be helpful for me to create my model with some logical end to it. So what that logic is, so in a linear regression, the function, the hypothesis function, that is uh, y is represented as f of x, a function of linear function of x. And what that function is, it is basically y is equals to mx plus c. Here m is the slope, x is the all the values array of the independent variable, and c is the intercept. So this will give me an array of all the y's, that is the prediction of y's. So in other words, I can also say y is equals to w1 multiplied by the x, that is independent variable, plus w0. So w0 is the weight of the intercept. Okay, so always the weights are one more than the dimensions in the total data. Okay, so let us keep this as our concept, and moving forward, what now we are going to do is we are going to scale our independent variable, because we don't want to feed our model with unscaled data. So I have already called this min max scaler earlier, so I'm going to rename it with scale, and I will fit transform it on the independent variable, that is x. So this will give me a scale data. Okay, this way I'll get an array. And now what we are going to do is we are going to split the data into train and test split. So for that we are going to use the sklearn model selection train test split, and we are going to split our data into 70:30 ratio. That is, the train data is in 70% ratio and 30% is the test data. And I'm going to first give x train x test, then y train y test. So this way I'm going to assign my values, and it will unpack the tuple that is obtained from this function. And this is the train test function that we are calling. And inside this we will give first the independent variable, then we are going to give y, that is a dependent variable, and then we are going to give a test size. And there are other parameters like random state. You can just check the documentation with which you can do some modifications. So now I'll execute it, and test size I've given 0.3, so this will split the test and train in this particular ratio. So now I'm going to call the linear regression model using the models linear model of sklearn. Okay, so I have called sklearn linear model, and I'm going to call this particular class linear regression, and I'm instantiating it with model, and then I'm going to fit it using my training data. So it is like x train and y train in this format. So first we have to get the independent features, then we'll go give the dependent feature, and we will fit it. So this will train our model. This will create a metadata of model, so that can be utilized for further analysis, and if finalized, this model will be our predictor. So now let us evaluate our model using the sklearn matrix, and we are going to call these three particular model libraries evaluation matrices, like R2 score. So this gives us the R square value, then this is the R square coefficient, which gives us the goodness of fit of the model, then mean absolute error, then mean squared error. And also we are going to create our own custom made adjusted R square to evaluate our model. So all the details about it, how these are calculated and the math behind it and how to utilize it, I have created a separate video on this, specifically explaining these things. So if you have missed that video, just go and check into my channel about this video. Moving forward, what we are going to do is first we are going to get the predictions from the model. So model we have already trained. Now we are going to get the prediction on the test data. If you remember, we have splitted our data into train test split. Now we also have a test data where we are going to evaluate our model, which we have kept aside as an unseen data for our model. So let's do that. So how we are going to do it? So we are going to do the predict function with the model that we have already trained, like model.predict, and inside the parentheses we will give the independent features of the test data. So this is how we are going to get the predictions. And just to check, so ypred, if I just want to check, so how will it be? So it looks like this. So these are all my predictions of the mileage based upon the weight variable. Hope you get it now. Okay, so now moving forward, how we can evaluate with mean squared error, mean absolute error. So I've already created using calling these functions that we have just called in this particular library. So let's see. So first of all, we'll calculate the mean squared error, and inside the parentheses I will give y test, and then I will give y predict. It is always to be remembered that we give the y test first argument, and then we give the y predict in this format. Otherwise the prediction, the score that is coming will not be the correct one. Okay, and then for mean absolute error also I will do the same, and for R2 square also I will do the same. And also I will create one more function which is not there, but we will create our own, that is the adjusted R square. So adjusted R square, so it is nothing but 1 minus this particular factor. And what is this? This is 1 minus R square multiplied by length of the total test data minus 1, that is length of the total samples minus 1, product of this divided by the length of the total samples minus the number of columns. In our case it is only one column, that is one variable or one feature, minus 1. So this particular factor, whatever this factor is, minus by 1 gives us the adjusted R square. So I'm going to execute it, and let's display this, how we can display this particular information. So I'll create a dictionary and I'll pass it into a data frame, and I'll pass that results uh, as a result, and then I'll execute it. So this way I get my results, that is the mean squared error I'm getting is 19.49 and mean absolute error is 3.25. R square that I'm getting is 0.66, which is requires lots of modifications, of course, with hyperparametric tuning and some more addition to some more variables. We can obviously improve this. Then adjusted R square, we are also getting quite similar to the R square. So this is how you can create your own simple linear regression model and try it out yourself. And so this was all in this video, from start collecting the data till creation of model and evaluating the model we have covered in this video. So I'll see you in the next video. If you haven't subscribed to my channel, please do subscribe it, and see you. Bye.